Chapter 4 of IS5 compares distributions, but this time for quantitative variables. So it's starting with wind speed for these forests. We get the histogram. Again, we saw this in Chapter 2, but now we can think about, for example, side-by-side histograms or side-by-side stem and leaf plots. The aspects here of the five-number summary are described and how we actually create and generate box plots. Box plot of a single distribution, not very interesting. More interesting when we have side-by-side box plots of multiple ones. We can actually see how they shift in various ways. There's some nice examples here, kind of thinking about some other examples. But we really want to start to look at aspects of outliers, for example, and these are defined in this section. Section 4.2 starts to talk about different outliers, which show up in various ways. There are rules for what it means to be an outlier. We can also think about the idea of re-expressing data. What if we actually do some kind of nonlinear transformation? And the example that's motivated here, it's a common one, is where compensation ends up being highly right-skewed. It has a very long right tail. So re-expressions are something we describe how to do in the companion materials in R, and the textbook talks about these other aspects. Turns out oftentimes re-expressing will equalize spread, which is going to be helpful for us later on. So really, only new thing here is we're thinking about comparing distributions, but for quantitative variables. There's some new idioms and some new commands in the IS5 and R materials for Chapter 4. In particular, we start thinking about the idea of the favstats function. Favstats is a function that will generate a whole bunch of summary statistics. It's the example of what we've seen before with this single variable in the mosaic package, tilde, and then the name of the variable will give us a summary statistic in the same way that the histogram function generated a histogram here for the wind speeds. Life's much more interesting when we have two variables. So here we can actually be thinking about the favstats comparing the fall and winter to the spring and summer by saying average wind speed, that's the Y in my parlance, and cat month, which will be the grouping variable. And so we get for each one of the cat months the different favstats. This aspect of kind of thinking about the mosaic modeling language we'll be using for graphics, for summary statistics and models throughout the course.